This lesson we're going to learn about common factors between two numbers and also the greatest common factor. This is something that we will use for fractions or to figure out which is the biggest number that goes into two numbers. So we'll start with refreshing our memory on how we find the factors of a number to begin with. So in 1.4 we found the factors of 30 by breaking it down to like 1 and 30, 2 and 15, 3 and 10, and then 5 and 6. Okay, also we did the prime factorization of a number, so this was the factors. Okay, the prime factorization looks a little bit different. So today we're going to be doing the prime factorization and the factors. But again, the prime factorization of 30 we found by doing the ladder method. So we would divide by 2, we would get 15. 2 doesn't go in, 3 does, 5 times. 5 goes in 1 time. So the prime factorization of 30 is 2 times 3 times 5. So again, they're a little bit different, but those are the difference between the two. So here's all the factors. All these numbers up here are the factors. And then here's the prime factorization, 2 times 3 times 5. So in example 1 it says find the greatest common factor using a list of factors. That would be finding all the factors of a number. And that would work a lot of the time unless we have a really big number. You're not going to want to list out all the numbers. So for example, in 24 and 40 there's really not that many factors, as you can see here. In 24 we have 1 and 24, we have 2 and 12, we have 3 and 8, we have 4 and 6. So that's all the factors of 24 right there. And then in 40 we have 1 and 40, 2 and 20, 4 and 10, and 5 and 8. So if you see all those factors, you can see the blue ones that have been highlighted. The 1s are a shared factor, 2s are a shared factor, 4s are a shared factor. Notice how 3 isn't circled because 3 is not a factor of 40. So 4s are a shared factor, but the biggest one, the greatest common factor of the two, is 8. So when it says to find using a list of factors, make sure that you list out all the factors of those numbers and then circle the greatest common factor. So we can see here they have the answer. The greatest common factor of 24 and 40 is 8. Here's probably more commonly what I will recommend that you do, especially when we start getting into bigger numbers. 12 and 56 really are not that big, but it's just easier if you get into a habit of finding the prime factorization of a number. So 12, again, they didn't show you the ladder method specifically. I'll do it off to the side here just so you can see it and be more familiar. 12, you break it down, 2 goes into it 6 times, 2 goes into 6 3 times, 3 goes in 1 time. So the prime factorization of 12 is what they have written here. So I'll write it off to the side over here as well. 12 is 2 times 2 times 3. And then 56, same thing. 56 we're going to break down. 2 goes in, let's see, 28 times. 2 goes in again 14 times. 2 goes in again 7 times. And 7 goes in 1 time. So here's the 56. We have 2 times 2 times 2 times 7. Now, here is the one time that you probably won't want to write out your prime factorization as a power. Remember in the previous lesson for 56, for example, when we got our answer for 56, sometimes we would put 56 would be 2 to the third times 7. When you're finding the greatest common factor, you don't want to do that. You want to go ahead and expand it out. Okay, so, and you'll see why here in just a second. So go ahead and make sure you write it out in expanded form. Don't crunch it down. So what they did, write the prime factorization of each number. We have it right here and over here. Once we have the prime factorization written, it's very simple what we do. We just circle what has a factor in each. So they circled the first set of 2's because it's a factor in each, and the second set of 2's. But notice nothing else is circled. There's a 3 by itself, there's a 2, and a 7 by itself. So the greatest common factor would just be these two factors, and when we find out however many it is, we just multiply up how many it is, and we find our answer. So the greatest common factor between 12 and 56 is 4. Okay, so here's where you're going to take some time on your own to find the answer to these first 6. If you do not get the same answer, go ahead and raise your hand, but I'll write the answers here in just a second. Make sure you follow the directions on these, because notice it says find the greatest common factor using lists of factors. So I'll help you start. Number one, you're going to start by listing the factors of 8. So you're going to say 8 is 1 times 8, and then it's 2 times 4, and that's all your factors. So we've listed out all the factors, and you're going to do the same thing with 36. You're going to list out all the factors, so 1 and 36. Then we have 2 and 18. Then we have 3 and 12. Then we have 4 and 9. And then 6 is a factor with itself because it's a prime. So, sorry that took up a lot of room there, but that's what you're going to do for those first 6. And then I'll just write the answers for the rest of them so you guys can check and see if you're right. Okay, so I started this one for you here, and your answer for number 1, the greatest common factor, is going to be the one that they share the biggest number of. So we can look 1, 2 they share, so 1 they share, 2 they share, 3 they don't share, 4 they share, and past that it looks like, since 8 is my biggest number, that they don't share anything else. So it looks like the GCF for number 1 is going to be 4. Number 2, 18 and 72. 18 actually goes into 72. So number 2, the answer is going to be 18 because 18 goes into 72. Number 3, if you were to list out all the factors, you would see that 7 is the biggest common shared factor between all 3 of those numbers. Now number 4, make sure you pause this for a second if you did not do 4, 5, and 6 this way. But number 4, remember, it says we're supposed to find the greatest common factor using the prime factorization, so you should have them listed out. So for example, on number 4, we should have broken down 20 using the ladder method. So I'm going to go ahead and break it down really quick here. Okay, so I have my ladder method on 20 is 2 times 5. And then I break down 45 the same way, 45 ladder method it. 2 doesn't go in, 3 does, 15, 3 again, 5. So here's 45 ladder method, 3 times 5. So if you didn't do the 4, 5, and 6 that way, make sure you pause real quick and do it that way. Okay, so I started number 4 for you here. You can see that they don't share a factor of 2 or 3, but they do share a factor of 5. So there's nothing to multiply with it because it's only one factor. So the greatest common factor of 20 and 45 is 5. Number 32, if you broke that down, 32 is 5 factors of 2, and 90 would be 2 times 3 times 3 times 5. So our greatest common factor for number 5 would be 2. And then number 6, we would end up getting 15. So again, raise your hand and make sure that you got those same answers with me. If you didn't, I can help you figure out what we did wrong. But make sure before you raise your hand for numbers 5 and 6 that you have everything that looks like number 4 for all of those numbers. So if you don't have the ladder method and the prime factorization, it's not going to do me any good in helping you. So make sure you have that before you ask for help. I'm not going to spend too much time on this, you guys. I probably won't give you one like this in your homework because really what it is just 4 regular problems within one multiple choice problem here. But we can kind of look at this and use process of elimination to help us figure out which ones won't be big right away. For example, 10 and 15, the greatest common factor between those two numbers is only 5. So letter A is probably not going to have a greatest common factor of 15 because 10 doesn't go into 15. 30 and 60, it's hard to say. 21 and 45, it's probably going to be pretty self-explanatory as well. Our factors of 21 are 3 and 7. So 21 doesn't even have a factor of 15 or that would multiply up to 15. So C is also going to be out right away. And then if you did the work and broke down the numbers using prime factorization or listed the factors, you would see where we would find 15 here. So it looks like they listed the factors instead of did prime factorization. So they did this like example 1, not example 2. But they listed the factors of 30 and they listed the factors of 60 and then 45 and 75. And you can see here the greatest common factor between 30 and 60 is actually 30. So they do have a common factor of 15, you guys can see here, but it asks which pair has the greatest common factor of 15. So this one, it's not the greatest common factor. 30 is the greatest common factor. So B doesn't work and D does because their biggest common factor is 15. So they gave the correct answer, D. Again, I just like to talk about these real life applications. Sometimes you'll have a story problem in there, sometimes you won't, but we'll go ahead and talk through this. You are filling piñatas for your sister's birthday party. The list shows the gifts that you are putting into piñatas. You want identical groups of gifts in each piñata with no gifts left over. What is the greatest number of piñatas that you can make? And then it says you're going to use the greatest common factor to figure out how many gifts to put in each. So you're going to use the numbers 18, 24, and 42 because that's what they gave over here in the problem. I know it's kind of cut off right now, but it's 18, 24, and 42. So it's 18 bottles of nail polish, 42 pairs of earrings, 24 pairs of earrings, and 42 lollipops. So what they did is they did the prime factorization. So they did this one more like example 2, and I sure would do that with 3 numbers especially. And then you guys can see the ones that they circled there. They circled a pair of 2s, a group of 2s and a group of 3s, and then they multiplied together, and it shows that they need to make 6 piñatas. So this one's kind of a challenging example. For number 7, I wouldn't worry about number 8 because with 6 more pairs of earrings, it would just change your factors a little bit, and you would add a factor of 2 and a factor of 3. So you would see if you have another group of 2s and 3s. If you want to try that, go ahead. If not, that's fine. But number 7 is kind of tricky because it says write a pair of numbers whose greatest common factor is 10. Well, if you look at this and you're completely confused, that's okay, but really all you need to do is think about this in terms of, okay, I want my biggest number that's shared between the two of them to be 10. So what I would do is I would pick one of my numbers to be 10 for this problem, and then just make another number that you know 10 goes into. So number 7, it's really not as hard as it looks, but they're trying to trick you. So if I say 10 and 50, well, I know that my factors of 10 are going to be 1 and 10, 2 and 5, and that's it. And then if I used 50, I would say 1 and 50, 2 and 25, 3 doesn't go in, 4 doesn't go in, 5 goes in 10 times. Let's see, 6 doesn't go in, 7 doesn't go in. Okay, so this is all of them. And then if you guys just see here, we have common factors of 1, common factors of 2, we have 5, and then we actually have our answer here. 10 is our greatest common factor, so there's our biggest one, and we're done.